Hi, welcome to this channel. Today and in this video, we will be discussing about statistics in which we will focus on understanding the measures of central tendency and dispersion for effective data analysis and interpretation. So let's start. So what is central tendency? It is a single value that best describes the sample data. So that is what it is. Single value that describes about the sample data, which is obviously in the center. So what is the purpose? It summarizes the data for easier interpretation. And as an example, so if you want to discuss about the antihypertensive medications, so average BP reduction of 20 millimeters of mercury. So this is how we describe it. So that is the central tendency of a particular drug. And there is something called as dispersion. So how do we define a dispersion? It's a variation in response to treatment or intervention. It shows how data is spread and the heterogeneity. So for example, one patient might have 2 millimeters of mercury reduction, another 22 millimeters of mercury. So even though there is a central value, but there are certain individuals or participants who might have different values. So this is captured by the dispersion. And we need to choose properly when we are trying to analyze any data. So this will help us to see whether the data is normal, skewed, or logarithmic. And based on this, we need to classify data whether it is qualitative and quantitative. And it depends on the research question what we are trying to demonstrate. One of the other central tendencies which we usually do is the mean. It is calculated with the sum of all values. Suppose you have five numbers, you will add them up and it divide them by the total number. What is the most common advantage? It's most common and basis for plenty of statistical tests. And when there are some extreme values, it will obviously affect the mean. So obviously, if there are some outliers that will obviously add up to the mean, and it will give us a wrong, or else it can misconstrue the central tendency. So for example, so mean example of the this one is the student heights. Suppose there are certain students which we have measured, and that is, for 11 students, these are the measurements, and if we want to calculate the mean, we need to do sum of all heights and divide them by 11. That will give us a result of 158.1 centimeters. So this is the central tendency that gives an average. In colloquial terms, mean is the average. Then comes the median. The median is we will usually arrange the the data in either like one order, that is the ascending order. Then we will locate this central value. So we need to identify, if we want to identify the median, that is the middle value is called as the median. For example, so 1 to 9, and 1 to 9, if we arrange it in an ascending order, 5 will be the midpoint of either of these one. So for example, you can see here 156, 159, 110, these are not arranged in proper order. Then if you want to arrange, so this sorted, this is the original data, then we sort it out. Then we do the median value will be this point. So on either of these, you have almost equal number. Okay, so we need to find that odd number. So for even numbers, we need to identify two values and we calculate the mean of the two values, and the median will be that. Okay, so in case of even numbers, we find the middle values. So usually it will be 2. Then we divide them by 2. We will take an average of that. Usually the value will be in between those two numbers. So at what are the advantages of the median? It is not affected by the extreme values because it's in the middle of entire values, right? So that's why. And better for non-normal distributions, and also ordinal data, the works with the rank data. Okay, so that's why the median has multiple advantages of this. Then comes to mode. It is a value in the statistical numbers where the most common or frequently occurring value, and usually we identify it by counting the frequency of each value, and this is best for bimodal or trimodal distributions. So mode is also a measure of central tendencies. So in this example, you can see here 156, 159 in this one. So 160 is repeated thrice, right? So the mode in this value set, data set, will be 160. So the mode application will be useful for bimodal distribution, and where you can see which numbers are more frequently to appear. And there is something called as geometric mean, where nth root of product of n values are taken, and it is useful for exponential or logarithmic data, such as it can be used for growth rates, antibody titers. Suppose on day 7 patient has an antibody titer of 2.9, and day 14 it is increasing, and day 29 28 again it's decreasing. So the arithmetic mean will be this sequential, you'll add up and divide them by the total number. Geometric mean will be the power, nth power of that. Okay, and we have completed this centeredness. So mean, mode, and median are the measures of central tendency, and geometric mean as well. And now coming to the dispersion measures. So these are range, variance, standard deviation, interquartile quartile range. So the range is the difference between the highest and lowest values. Variance is the square of the standard deviation. Standard deviation is the average distance from the mean, and interquartile range is the middle 50% of the data, which will define and also will affect the entire data set. Okay, so that is these are the measures of the dispersion. So range is simply a basic measure of dispersion that will show the spread of extreme values, highest and the lowest. So that is called as range. Major advantages include it's simple to calculate and it's easy to understand. It pairs with median. Disadvantages include, there can be some outliers, and there can be few outliers. Because of that, the range you know will be affected, and it ignores the data distribution, and usually it has limited statistical use. There is something called as percentiles. We divide percentiles. It has, you know cent in it, right? It has cent in it. Cent means 100. So we divide data into 100 equal parts to understand the distribution. And usually 25 percentile means 25% of the observations fall below this value. If it is 50th percentile, half of observations below this value. 75th percentile means 75% of the observations fall below this value. Okay, so similarly, we call percentiles into quartiles. We divide into 25, 25, 25. Okay, so first quartile means 25, so 1/4. And second quartile will be 50th, that's median. Third quartile will be 75th percentile. Fourth quartile will be 75th to 100 percentile. Interquartile range, it's the difference between the 25th and 75th percentiles. Calculation will be Q3 minus Q1. And what is the advantage? It's not affected because it's a middle portion and it's a major portion of the data set, so it's obviously not affected by that. So for example, So median and interquartile range in healthy volunteers of, you can see, will be charted in this category. So this is the 50th, 75th, and this is the 25th percentile. And it can be represented in visually as box plot. It gives us about idea about the median, interquartile range, and potential outliers. It has immense, its application will be used for skewed biochemical data. Now coming to the standard deviation. Standard deviation is a measure of spread around the mean. So larger standard deviation means greater heterogeneity. And it's not for qualitative data, it's only for quantitative data. So for example, blood pressure data mean systolic pressure BP is 130 and standard deviation is 10 millimeters of mercury. How do you interpret it? So it is expressed as 130 plus or minus 10 millimeters of mercury. So the patients can range from 120 to 140 millimeters of mercury. So that is the standard deviation. And usually we distribute into first mean plus one standard deviation, mean plus two standard deviation, mean plus three standard deviation. So this is how we define it. Geometric standard deviation, it is the dispersion measure for geometric mean, and it is used with logarithmic data similar to the earlier example which we have already learned, that is for the antibiotic titers and growth rates. And then if we square the standard deviation from mean, this is called as variance. So it is used in advanced statistical analysis. There is some term called coefficient of variation. It is a relative standard deviation. Usually coefficient of variation is calculated in percentage, standard deviation by mean into 100. So it's a relative in terms of we do it for the 100, compare it for 100. Then we compare dispersion across different units. So this is the dispersion across different units is calculated by coefficient of variation. So coefficient of variation example, if you want to learn, is if the known value is 10 milligram per ml, the measured values are 9, 10, 11, and etc. Mean is 10.27, standard deviation is 1.07, coefficient of variation will be mean, as you can see in this, standard deviation by mean into 100. So standard deviation is 1.07 by mean, that is 10.27 into 100. So that will give us the value of 10.4%. So it is used to assess the measurement precision and also compare dispersion across different units. And it also is useful for monitoring production consistency. So these are the distribution measures. Central tendency, it is arithmetic means, it represents center point. Dispersion, again, standard deviation quantifies data spread. Notation results typically reported as mean plus standard deviation in scientific literature. So there can be some skewed distribution measures as well. Central tendency, usually median is preferred, and these are for normal distribution. Mean is used for normal distribution. Standard deviation is quantified for, for normal distribution, and is notated as mean plus standard deviation, and this one, okay, normal if it is normal. When there is a skew distribution measures, the central tendency measure will be median, and range or interquartile person range will better captures the spread in skewed distributions where standard deviation may be misleading. Then the notation will be reported as median, minimum or maximum, or median plus interquartile range in this. So logarithmic distribution measures geometric mean represents the central value in logarithmic. Geometric standard deviation measures how widely values are dispersed, and the examples include antibody titers, bacterial growth rates, and other biological measurements that follow logarithmic pattern. So the take home message for this one is, for normal distribution you will use arithmetic mean, and with measures of dispersion will be standard deviation. Skewed if it is skewed distribution, median will be used and range with interquartile range will be used. Exponential or logarithmic distribution, we use geometric mean and geometric standard deviation. So common mistakes which we usually, researchers and also the clinicians do are, income distribution, mean pulled higher by a few wealthy individuals. That is the mean. And median better represents a typical home. And when we do test scores, if you very low scores skew mean downwards, obviously. So the outliers will affect the mean. That is the common this one. And the standard deviation versus range. So if we use all data points, more stable measure, and for normal distribution, standard deviation is useful. If you have only, you know, standard deviation uses all data points, but whereas range uses only 2 points. It is affected by the outliers and it is for the skewed distributions. So, and other than that, so the common mistakes for qualitative data: don't calculate mean and median or standard deviation for categorical data. Usually, we require frequencies, occurrences in each category. We report percentage, show proportion in each category, visualize appropriately, use bar or pie charts. So, for example, blood pressure, mean systolic is 130, standard deviation is 10, and 68 patients have between 120 to 140. Similarly, like 4.95 arithmetic mean, geometric mean, and 11.8, these ranges. So we have to present it accordingly. So distribution of student heights, scatter plots, and also student box plot. This is the median with standard interquartile range, and this is the mean. Okay, so based on this, we'll properly represent them visually. So other than that, so if you have an coefficient of variation which you have already seen in the earlier slides, so measure sample known value, then calculate coefficient of variation. So interpret result as 10% variation from the actual value. So we need to use right visualization for properly demonstrating and also notating the data which we have analyzed. So histograms are useful for frequency distribution. Box plot is for usually median and quartiles. Scatter plot for relationships between variables. To report in research papers, we need to, state the distribution type: normal, skewed, or logarithmic. We need to choose appropriate measures matched to the distribution type. Report consistently, use the same format throughout. Okay, so that is what it is in reporting. Normal distribution reporting will be format. Now, if it is normal distribution, obviously you will use mean with standard deviation, and you need to interpret as well. Once we have to mention in mean format, then example, then interpret it accordingly for the clinical use. If it is skewed, format, example, and interpret. And logarithmic distribution as well, format will be geometric mean. Example is examples are like, antibody titers. Interpretation will be accounting for exponential changes. The various software tools are there to, make our lives simple. There is something called as R software. It is free, powerful SPSS, usually for social sciences. Python, versatile, growing statistical library, and GraphPad prisms. These are major software tools which you can use. Beyond basic measures, advanced statistics, we use regression, ANOVA, multivariate analysis, inferential statistics, hypothesis testing, confidence interval. And for descriptive statistics, we require central tendency and dispersion measures. So when to use mean versus median? We use mean when there is normal distribution and no extreme outliers, when that is a continuous data. We use median when skewed distribution is there and presence of outliers and ordinal data. When to use mode? It is for categorical data, and we use it under the most common category which we count them. And if there are two, bimodal distribution, two distinct peaks are there, like Hodgkin's disease, So we use mode in these situations. Geometric mean for anything logarithmic expression of the data, we use that, such as antibody titers, bacterial growth, financial returns, compound growth rates. So these are the things where we use that. So all obviously this is just a revision of what we have already learned. The standard deviation for normal distribution with mean and parametric tests. Interquartile range is for skew distribution with we use it with median and non-parametric data tests. So we need to check the data distribution, appropriately represent it, and the for checking data distribution, you can check it inspection, visual inspection, that is histograms and QQ plots, with statistical tests such as Shapiro-Wilk, Kolmogorov-Smirnov's test. With rule of thumb, if standard deviation is more than half of mean, likely skewed. To transform non-normal data, we need to identify the skewness with either visual inspection or statistical tests. We need to apply transformation, logarithmic or square root or reciprocal. Verify normality again after doing the transformation. So when we have outliers, we need to identify with box plot or z-score method. We need to investigate whether it's an error or genuine extreme value. We need to remove only if measurement error is there, and we need to report document handling of outliers. Sample size consideration. For larger samples, more reliable central tendency estimates, and for smaller samples, it's more affected by the outliers. Power calculation, it determines adequate sample size. So we need to consider all these things when we are doing the sample size calculation for larger, smaller, and for power calculation. And presenting data visually accordingly, box plot, histograms, and scatter plots are appropriately visualized. Data should be visualized accordingly. Common pitfalls to avoid is wrong measures using mean or skew for skewed data, ignoring distribution, and overlooking outliers. And there are some misleading visual which will because of poor graphic choice or scaling. So you need to use proper measure. We need to check the normality. We need to investigate the extreme outliers, and good graph choice are required to avoid the pitfalls. So the key takeaways of this entire presentation will be you need to match the distribution. Normal, mean plus standard deviation, skewed, median with quinterquartile range. Simple. We need to check the data distribution first and it present it visual, like by visual or statistical methods. Choose appropriate visualization technique and report it consistently to make it a genuine one and also an original one, and the consistency is key here. So thank you very much for tuning in. Please join for further sessions. Like, subscribe if you enjoy these videos. Thank you so much for all your time.